Okay, hello and good day everyone. We are from L01 B03. We represent our task problem-based learning, which is the Positron Emissions Tomography (PET). Before I'm starting with our presentations in details, I will introduce myself and my friends. My name is Ainiena Syafienasz and I accompany with Afifah Amirah, Muhammad Haziq, Syahmi Malik, Hairi Ezzanie and Ammar Husaini. So I'm leader today and will conduct the PBL sessions meeting. So for the first one, we go to the introductions. As we know, the positron emission tomography is the scanner in biomedical imaging that allows the doctor to check disease in the body. It depends on which part need to examine, as the biomedical engineer must need to know that the PET scan have radioactive in very hazardous if not taking to handling with extra precautions. In this hour meeting, we will discuss the appropriate disposal procedure of PET scan in compliance issue that related to disposal PET modality with Act 304 and will be analyzed accurately to determine the most appropriate way to dispose of the PET modality that complies with the Atomic Energy License Act 304. Okay, for the first part will be presented by Muhammad Haziq. Please welcome.
All right, thank you, Ainiena. Okay, I will talk about the power requirement and performance and safety standard as stipulated in Malaysia Standard bracket MS 838 year 1985 Code of Practice for Radiation Protection of Medical X-ray Diagnosis. Okay, the finding first I have found is the accuracy number 9.2 in part 4 safety and performance requirement of X-ray system. Okay, the difference between actual peak and indicated preset peak in kilovolt during exposure must be below than 5% of indicated or preset value, and the difference of actual exposure time and preset exposure time must be below than 10% of preset time. Okay. Okay, next for number 9.5 is the assessments of performance criteria. There is 4 assessments that need to be highlighted. The first one is both success parameters must be evaluated using at least 10 consecutive measurements taken over a 1 hour cycle. Okay. The second assessment is after each calculation, all variable control for technique factors must be changed to alternative setting and then reset to the test setting. The third assessment is the X-ray unit must be attached to an electrical power supply that meets the machine's specifications for these assessments. And the last assessment is the measurements must be taken with correctly calibrated radiation dosimeters and other instruments. Okay, that's my part, my presentation. I will pass back to Ainiena.
Okay, thank you for the Haziq for more informations. Okay, the point we got from the Haziq, we know that the power requirement having a performance as well. The in safety standard that related what mentions to accuracy is the actual exposure and presets. Also has been mentioned about performance and safety standards as stipulated in Malaysia Standards 838, especially in terms of the codes of practice of fraud radiation protections. Thank you Haziq for the wonderful explanations. Now we go to the second part regarding to the radiation emissions mechanism of PET. So I will express about it, which is will contribute to the safety hazard concerns. Before I'm going to the details, I would like to give some explanations about the radiation protections. So actually, we constantly every day exposed to radiations, which is the part of number of sources, including materials environments such as the radiant gas in our homes or outdoor spaces in our environments. This is we call the expected ground radiations and very close in the country. So in the first mechanism of PET that will contribute to safety hazards concerns in surrounding. So the first one is the positrons emit to surrounding. Is when the positrons interacts with an electrons, the resultant annihilation process converts the mass of the two oppositely charged particles into the 511 kilovolts gamma photons. If the gamma contrast involved in the radiation split, the maximum in positrons energy are distance as less range of maximum distance these particles can travel into the air. So the distance the positron travels before is annihilation is directly proportional to its initial energy and inversely proportional to the density of the materials it was being absorbed. This plastic string was wall thickness of the approximately 1 millimeter. Some positron and most positron emitted can penetrate the string wall and produce ionizing events outside of the needle. In the air, the positron can travel over 6 meters and can travel almost to 12 meters before being absorbed. So it can cause safety hazard concerns to the nearest people. Okay, the second point is exposure to staff working. When we want to conduct the PET scans, there must be the doctor or staff will conduct the patients. Therefore, it will expose to the staff working. This is because the potential hazard of the positron emitting radio have a risk which is possible in very change develop cancer in long term from the radiations and injections bleeding or bruises or at the site of intravenous injections. Okay, while for the third point is the material used for shielding in PET facility. As we know, the lead and concrete are most likely material to use for the area shielding in the PET. The attenuation factor necessary for shielding is likely to be no more than 10, but the high penetrations of 550 kilovolt photons can require significant thickness of either materials. The shielding are used is to for reduce the exposure of radiations. So the next point in the second part, it will be continued by Afifah.
Okay. Okay, thank you, Ainiena. I'm Afifah. I will continue to the other point in part 2, which is ionizing potential of a positron. For your info, when a positron interacts with an electron, the resultant annihilation process converts the mass of the two oppositely charged particles into two 511 kilo electron volt gamma photons. While the energy of this gamma photon is the same for all positron emitting radionuclide, each positron emitter has a characteristic spectrum of positron energies based on the sharing of the initial energy between the positron and the neutrino. The distance the positron travels prior to its annihilation is directly proportional to its initial energy and inversely proportional to the density of the material it is being absorbed in. Generally, plastic is a better attenuator of positron than water. A disposable plastic string has a wall thickness of approximately 1 millimeter. Some of fluorine-18 positron and most of the positron emitted by oxygen-15 and rubidium-82 are able to penetrate the syringe wall and produce ionizing events outside of the syringe. In air, the positron can travel over 6 meters and can travel almost 12 meters being totally absorbed. This can cause safety hazard concern to the nearest people. The next point is a small risk of cancer. For the small risk of cancer, low-level radiation exposure has no immediate health consequences, but it can lead to long-term health problems. So, a slight increase in cancer risk over a lifetime. There are studies that monitor group of people who have been exposed to radiation, such as atomic bomb survivors and workers in the radiation industry. According to these studies, radiation exposure raises the chance of developing cancer and the risk increases as the dose increases. Hence, the higher the dose, the greater the chance of developing cancer. In contrast, the risk of cancer from radiation exposure decreases as the dose increases. The last point is a high dose of PET radionuclide. It is necessary to limit exposure so that no individual receives more than 100 mrem per year. Total effective dose equivalent 1 mSv per year from the licensed operation once a week. This entails limiting the dose to a level of 2 mrem. This amount of roughly 30% of the total. There is an additional effective dose rate from natural background radiation. The dose rate is areas accessible to the public must not exceed 2 mrem in any given hour, 0.02 mSv per hour. Members of a public area institutional staff members whose assigned duties do not involve exposure to radiation sources. So that's all from my explanation. I will pass to our leader, Ainiena.
Alright, thank you Afifah for your explanations. Okay, for the next part, I will pass to the Syahmi. Please come. Thank you.
Hello. Okay. For part 3, I will explain about the half-life of radioactive and its implication to the disposable of PET. So as you can see on the slide, there are two types of half-life that I will explain. The first one is half-life of radioactive. Half-life can be simply defined as the time taken for one half of a nuclei in a sample to decay, which means that change spontaneously into other nuclear species via way of of emitting particles and energy. So the time of radioactive reaction of unstable atom to become stable one is called a half-life. And to characterize the exponential as well as non-exponential decay, different isotope have a different half-life. So the half-life of the reaction can be defined as T and a half. So the half-life of radioisotope, the radioisotope used in PET to label tracer fluorine 18 that has a physical half-life of 109.8 minutes. So this radioactive form of natural element will pass through the body and be detected by the scanner. So virus drug and other chemical can be labeled with this isotope. Fluorine 18 often used in development of radiopharmaceutical due to its favorable physical and nuclear characteristic. So as you can see, this is the formula that that can calculate the half-life of a isotope, which is T and a half equal to ln 2 divided by the lambda. So the implication to the disposal of PET. So short half-life radionuclides like fluorine 18 should be separate from those of longer half-life. And after 10 half-life, the dose rate shall be measured before sent to the third party for disposable process. So there are several variety radioactivity which is produced using PET scan. In general, radioactive waste may be divided into solid radioactive waste, liquid radioactive waste, and human or animal radioactive excreta. Short-lived and long-lived radioisotope may also be segregated for disposal. So the regulatory authority allows certain disused radioactive source with radiation below the clearance or exempt level to be disposed away as a common or biomedical waste. Appropriate policy and protocol must be available and abide in the disposal of radioactive waste. So I think that's all from me. I will pass back to Miss Ainiena Syafienasz.
Okay, thank you for Syahmi for your energetic presentation. So for the next part, I will pass to the Hairi. Please welcome.
Okay, thank you, Ainiena. My name is Muhammad Hairi Ezzanie and I will explain about the radioactive waste management. Okay, the main objective of radioactive waste management are to ensure the protection of individuals such as public, radiation worker, patient, and the environment from the radiation exposure exceeding safety limits. Okay, next is healthcare institution generate amount of waste which is considered as potentially hazardous for dissemination of infection. On average, the hospital generates about 0.5 and 2 kilograms of radioactive waste every day. Okay, the management of radioactive waste involves two stages, which is collection and disposal. For collection, radioactive waste should be detected and isolated in the working environment. When collecting radioactive waste, avoid using glassware. Each bag or trash can must be labeled with the name of the isotope, the activity level, and the data of monitoring. Okay, for the disposal, each package should be monitored and its activity level should be marked. Some hospitals that have incinerators and allow the treatment of combustible radioactive waste through incineration may also distinguish combustible radioactive waste from non-combustible waste. Okay, next, there are four common methods for radioactive waste disposal, which is dilute and disperse. Okay, the second one is delay and decay. And for the third is concentrate and contain. And the last is incineration. Okay, next, there is a special situation for the disposal of radioactive waste in a hospital, which is disposal of sealed source, the disposal of gaseous waste, and the lastly is the disposal of management of cadavers containing radioactive material. Okay, I will explain about the disposal of sealed source. Okay, the hospital using this application must sign a contract with the providers for the safe removal and replacement of the sealed radioactive source. Okay, for the disposal of gas waste, the disposal of this radioactive gas must have an efficient airflow system to ensure that the gas is disposed of properly without harming human health and the environment. Okay, the lastly is for the management of cadavers containing radioactive materials. Okay, disease like thyroid cancer receive a high dose of iodine 131. Sometimes the patient may die and still have the very high levels of radioactivities in their body. In this situation, the patient should be informed of the officers. Must be disposed of by burial or cremation without special precautions. Okay, that's all from me. I will pass back to our leader, Ainiena.
Alright, thank you, Hairi, with a good information. So the last part I will pass to Ammar. Please come.
Thank you to Ainiena. For disposal modality, decommissioning is removal of a medical device from service in a healthcare facility after a decision to invest in the device itself or in the service which is used. The factor that determine which are the pathway of decommissioning is followed by categories of intrinsic to the device and to the infrastructure. For factor intrinsic to the device include single-use designation, inadequate disinfection or sterilization, unresolved performance issue, unresolved safety issue, continuous unreliability or history of serious failure, high cost of repair making the device cost effective or financially unavailable and end of life. For the factor related to the infrastructure, reorganization, closure or relocation of the healthcare facility, shortage of local technical support, spare part, accessory or consumable. Next is infrastructure, incompatibility, serious concern about unreliable cybersecurity for network device, and a catastrophic event such as accident, emergency or disaster that may compromise the function of the device. In some other cases, when PET scanners are not disposed, it can be used in a way of refurbishing, reprocessing, upgrade, donate, sell, or trade in and reassign internally. For disposal procedure for PET scan, the first one is risk auditing and cost assessment. Costs should be considered such as site alteration, machinery and accessory disassembly, installation and shipping labor, consumable service, repair servicing, personal protective device, training and insurance can be part of the cost. For next is for the personnel, all should be involved when system need their decommissioning skill. A safety officer have a significant part to play in ensuring that decommissioning is carried out safely without affecting the climate. The public or health staff, personnel that is responsible for the commissioning of the device should have proper training, qualified and competent in order to avoid any risk of radioactive hazard. The next is infrastructure. Since medical instruments are often huge and bulky, Transport can be required special equipment, and a passage may need to be secure for widening or demolishing a wall to carry a bulky equipment out. The time required for big system to be decommissioned should be also be considered and prepared. The decommissioning of higher risk medical equipment may involve a skilled contractor. The next is decontamination of a device. Decontamination of all decommissioning of all single-use and reuse medical equipment involve decontamination. Both medical equipment used or currently used must be washed, as specified in the particular guideline for the patient or type of device. The procedure include disassembling, cleaning manually or mechanically, and lastly disinfecting. For the removal of patient data, in order to preserve personal information and patient safety, patient record and information contained in medical device should be erased or deleted by the individual responsible for the information before the medical system is decommissioned. If the system is designed for cloud storage, it is important to deactivate the IP path connecting the system to the server. The next is waste management. Waste management means that health staff, the public, and the community are healthy and minimally impacted. For better reporting, auditing, and procedure, a waste management system may be implemented into environmental management system. And the last one is inventory system and decommissioning report. It is important to record and the decommissioning of each medical equipment when the item is disposed of, donated, list, or trade in. The next step is to delete or preserve the item listing from the inventory log. The material to be used in the report on decommissioning may include date of decommissioning, type of medical device, condition of device before decommissioning, and reason for decommissioning. I think that's all for me from now. Then I will pass back to leader Ainiena.
Alright, thank you to Ammar for the wonderful explanations. Okay, by now we will conduct the questions and answer sessions between members to know what are the curious. So you all can ask now.
Haziq, can you hear me?
Yes.
Okay, Haziq. I got one question for you. Okay, can you tell me what are the performance criteria as stated in part 4, number 9.5, as you mentioned before?
Okay. There are two performance criteria that can be highlighted, can be focused on. Okay, the first one is all X-ray system should be tropicalized. Okay, and the second one is for any X-ray system that is not tropicalized, the supplier of the X-ray system could advise the user as to what suitable temperature and relative humidity it should be kept. Okay, here the meaning of tropicalized is the X-ray system must be maintained temperature at quite high temperature. Okay, that's my answer.
Oh, okay. Thank you, Haziq, for your answer.
I have a question regarding this topic to Ainiena and Afifah. In PET scanning, there is a radioactive substance called FDG. What does FDG do? And the next one is how much the radiation does a PET scan emit? That's all.
Okay, thank you Ammar for your questions. So I will explain for your questions, which is the regarding to the what FDG do is. Okay, so as we know that FDG is the basic sugar like a glucose, which stand for the fluoride oxyglucose, is a radioactive substance used in the PET testing. The FDG are used for diagnostics purpose, and the fluid oxyglucose injections is used to assist assessments of a cancer, coronary artery disease, or epileptic seizure. So the FDG is injected into the bloodstream and accumulates in the body, where it gives off energy in the form of gamma rays. So the FDG PET tracer produce the color code image of the body that show both normal and cancerous tissue. So the spectral analysis and white counting use sources from the beta or gamma reference.
Okay, for the second question that Ammar asked about how much the radiation does a PET scan emit. For this, before that, the amount of radiation exposure from an imaging test depends on the imaging test used and what part of the body is being tested. And some of imaging tests have higher exposure. So based on Ammar's question, how much the radiation of PET scan emit is a PET scan exposed exposed to you about 25 milli-SV of radiation. This is equal to about 8 years of average background radiation exposure. So I think that's all from me. I have a question to Syahmi. Uh, Based on your point in part 3, can you tell us about the isotope that used for positron emission tomography and their half-life?
Alright, Afifah, thank you for the question. I will explain that for the isotope used in PET scan, commonly used fluorine 18. The fluorine isotope with a half-life approximately 110 minutes. So there are other isotopes that used in the PET, which is carbon 11 with the radioisotope of carbon with half-life 20 minutes, nitrogen 13 isotope of nitrogen with half-life approximately 10 minutes, and the oxygen 15 with an isotope of oxygen having a half-life about 2 minutes. Why the most PET scan use the fluorine 18 is that this tracer is very useful because of its long half-life and because of its decay by emitting positron having the lowest positron energy, which contribute a high resolution image acquired. Okay, is that clear for you, Miss Afifah?
Clear. Thank you for your clear explanation, Syahmi.
All right, welcome. So, I also got a question for Mr. Hairi. Hairi, can you tell us how many types of radioactive waste that need to control?
Okay, thank you for the question, Syahmi. Okay, there are only 4 types of radiation waste, which is low level waste, intermediate level waste, high level waste, and very low level waste. Is that clear, Syahmi?
Yes, thank you for the explanation.
All right.
Okay, Hairi, I have one question to you. Okay, can you explain the more details what is concentrate and contains regarding to your collected radioactive waste and why you said it's the rarely used? Can you explain to me?
Okay, thank you, Ainiena. Okay, I will explain about the concentrate and contain. Okay, this technique of radioactive waste disposal is sometimes used for radioactive material with very high activity levels and for those with long half-life, which is longer than a month. Okay, this method of radioactive waste disposal is rarely used. Okay, is that clear, Ainiena?
Yes, clear. Thank you,
Okay,
Hairi.
all right.
Okay, Amma, I got a question for you. Actually, I don't really understand about the term of single-use designation as you stated before. Okay, can you please briefly explain it to me for my better understanding?
Thank you for the question. The question is about single-use designation. Am I correct? The single-use designation device also can be known as a disposable device. This kind of device designed for use on one patient only during a single procedure. The device strictly banned from reprocess, like cleaning, disinfecting, or sterilizing, and later to be used on another patient. The reason is to avoid infection to the other patient, which may cause more severe disease or even worse, death. So that's why the single-use designation device must be disposed properly. I hope that answer your question.
All right, Amma, thank you.
Alright, thank you to all. So we know and understand and achieve the autonomy energy licensing at 1984, and which understand the every details as stipulated inside the act to ensure the management of irradiating for medical is adequately taken to ensure the safety for everyone. So from here we can conclude every step that we need to carefully and wisely to the radiations, because radiations have always have in surrounding environment. So we can conclude that we know how to manage to the best way and procedure to dispose of the modality of a positron emission tomography PET. So thank you everyone for the extra commitment for the problems based learning today. Thank you again.